Hello everyone, this is a Unit 2 review sheet video. We're going to go over every single question on the review sheet. Hopefully this helps you out. Let's start with number 1. Number 1 says the graph of the function is shown below. Describe each section as linear or nonlinear and increasing or decreasing. So in section N, and we're going to just highlight each section as we go. Section N is right here. So section N. So as you can tell, that section N is in yellow here, and that is linear. It's linear because it is a straight line. And it is increasing because it is going up from left to right. Going on to the next section, section P, is this section right here. That is also linear and increasing. And section Q, right here. Right? That is also linear, but it's not increasing or decreasing. The horizontal line, remember, has a slope of 0. Horizontal line, slope of 0. And the last section right here, which is section R, is linear and increasing. All right, so number 2. The owner of a coffee shop compared the amount of hot coffee per day in fluid ounces sold and the daily high temperature in degrees Fahrenheit per day. Her data is shown in the scatter plot below. The data is modeled by this equation: y equals -5.9x plus 850. Identify the slope and the y-intercept and explain what they mean in the context of the problem. So the slope is the number that is before the x. So this is called the coefficient, and that is the slope. So, and that means, what this means in the identification right here, that x right here, identify the slope. What does it mean in this context? All right, so the y-intercept is the other number. What does that mean in the context of this problem? So the amount of fluid sold, the amount sold in fluid ounces of this coffee is 850, the y-intercept. So the coffee sales, and you're taking a look at the temperature. So this temperature of 0 degrees, when it's 0 degrees out, means that at 0 degrees Fahrenheit, they sold 850 fluid ounces. Of coffee. That is the starting amount. This is the initial value. All right, so what does the slope mean? Well, -5.9. So if you're figuring out the equation of this trend, of a trend line, think about it. I'm going to draw this trend line starting from right about here and going down. What's actually happening as the temperature becomes higher, right? There's a decrease in hot coffee sales. So, as the temperature increases, the coffee sales decrease. And I wrote that right there. And coffee sales decrease by 5.9 fluid ounces per degree, going down. All right, as the temperature increases, the coffee sales decrease by 5.9 fluid ounces per degree. And that is number 2. All right, number 3, draw the line of best fit. And this is the same question. So we're going to draw that line. I did draw the line on the other one, and it looks just about the same. Let me move this down just a little bit more. And it's supposed to go directly in the middle of all of those points, drawing it. Number 4, in City W, the average cost of a gym membership is given by the equation y equals $34.99 x plus 49, where y is the total cost in dollars for x months of membership. So, what is the sign-up fee? Well, remember, the sign-up fee is always the b, the y-intercept. So the sign-up fee before paying for any month in the gym is $49. What's the average monthly cost for the gym? Well, the average monthly cost is the slope. That's the rate. So $34.99 per month. How much does the gym cost after 1 month? After 1 month, how much does the gym cost? Be careful with this. Use the equation, right? So I'm just going to take the equation down. Y equals $34.99 times 1. Substitute that 1 in for the x for the months plus 49. So we are going to bring up this calculator and we are going to use it. $34.99 times 1 plus 49 and enter $83.99. That's after the first month. That's including the first month charged and the initial fee of $49. So I'm just going to go ahead and substitute 2 months now in for the x. Always substitute, use that equation times 2 plus 49. I'm going to bring up the calculator again. And I'm going to type $34.99 parentheses 2 plus 49. Enter $118.98 for gym for 2 months. All right, so that's it. So that was number 4. Number 5, find the slope of the line. Pretty easy question. Remember, the slope formula for when you have 2 points and no graph is y2 minus y1 over x2 minus x1. So we have slope formula, and we're going to set that up with the minus sign and the minus sign. We are going to label x1 y1, x2 y2. What's easy about this is that there are no negatives, 16 minus 6, and 3 minus 1. So that is 10 over 2, and the slope is 2. Sorry, the slope is 5. Remember, you could use your calculator. 16 over 6, you could put alpha x, 16 minus 6 on the top, and 3 minus 1 on the bottom as the numerator, and denominator, and 5 would be your answer. Numerator up top, denominator on the bottom, and you get your 5. Slope of 5. Number 6. Which graph shows a function in which the rate of change, which is the slope, and the y-intercept are both negative? So slope, we're looking for a line that goes down from left to right. And then y-intercept below the origin. Okay, this is going up. This is a positive slope. That's out. Here's a positive slope. That's going up. That's out. Negative slope. Negative slope. Negative. It's going down. Negative. Going down. The y-intercept has to be negative below the origin. Right here, that is a y-intercept that is negative. This is a y-intercept of 0, 0. C is your answer. D is out. Right? Both the slope and the y-intercept have to be negative. Let's go on to number 7. The points 4, 1, and x, negative 6 lie on the same line. The slope of the line is negative 1. What is the value of x? Pretty tricky question, right? So the slope, to figure out the slope, actually you don't have to figure out the slope. They gave you the slope is negative 1. But to figure out slope, you do have to have 2 points. And we don't. So what you do when you are confused, you always substitute. Let's go ahead and substitute. Remember, this is your x1, this is your y1. This would be your x2, this is your y2. So let's go ahead and figure out what we're going to do. This is y2 minus y1 over x2 minus x1. And we're going to use that and substitute. You know this negative 3? I do not want to use it because it's a negative. So I'm just going to go to 3. All right, so I'm just going to go and put 3, this 3 in for this x. All right, so I have negative 6 minus 1 on the top. That's y2 minus y1. And instead of x, I'm going to put 3 minus 4. Okay, so m is negative 7 over negative 1, which is m equals 7. B is out. Okay, let's go on to this one. So m equals, instead of 3, we are now going to substitute this 9 in for the x. Let's go and do that. So we have y2 minus y1, which is negative 6 minus 1. And then we have x2, which is now 9 minus 4. So let's see. Negative 7 over 5? That's not 9. That's not negative 1. It's supposed to be a slope of negative 1. The slope has to be negative 1. It's not. Right? It's not here, and it's not here. So this is out. Let's go over to D. So instead of this, so I'm going to put 4 comma 1, and instead of x, I'm going to put 11 comma negative 6. All right, so we're going to label x1, y1, x2, y2. And we're going to use the slope formula again. We're going to set that up, minus minus, negative 6 minus 1, and 11 minus 4. All right, so, I mean, you could take your calculator and do it. So we're going to have alpha x, negative 6 for the top, your numerator. And going down to the denominator, 11 minus 4. -1. That is it. We do not have to try. See how I avoided A? Because it was negative. I mean, it was fine. I mean, we could use the calculator and everything. D is your answer. When you substitute 11 in for this x, you will get a slope of -1, and that's it. That's how you do number 7. Number 8, the graph of a function is shown below. Which interval of x is increasing and linear? All right, so increasing and linear. Increasing and linear. So between -4 and -2. All right, so -4 and -2. This part. -4 and -2. That looks like it's increasing and linear. So I'm going to choose that as my answer. Between -2 and 0. That's this part. All right, that's this part right here. That is not linear. That's out. That's non-linear. Right? 0 and 2. This again is non-linear. It's increasing, but it's non-linear. And then 2 and 4. It's going down from left to right. So that's not increasing, it's decreasing. It's linear, but it's decreasing. So it's supposed to be increasing and linear. A is your answer. Number 9, find the slope and the y-intercept of the linear equation below. Remember, this must be in this format, y equals mx plus b. So we are going to solve it for y. Subtract the 4x on both sides. Remember, you subtract the 4x on both sides. You're going to cancel this out. You're going to get 8y equals -4x plus 24. You divide by 8 on both sides. Remember, you keep that fraction for the slope. I'm going to do -4 over 8. -4 over 8. If you do not know what that means or what that is, put -4 over 8 in the calculator and press enter. That's -1/2. It'll give you a -1/2. That's what you reduce it to, -1/2 x, and then it's 24 divided by 8 is 3. So the answers are: the slope is -1/2 and the y-intercept is 3. You have to get the equation into y equals mx plus b format. That is slope intercept format, and then you could figure out the slope and the intercept of the linear equation given. All right, so number 10, as a part of a training program, Marcy completes a 3-mile run a few times each week. The scatter plot shows the times Marcy completed the run. Draw the line of best fit. So we are going to draw a line of best fit right here, going through the center best as we can. All right, so taking a look, that is good. Right there and right there. All right. Write the equation of the line of best fit determining the slope and the y-intercept. So right now I'm going to say that this is the equation of, this is the y-intercept. So I'm going to put b equals 30. Right, I don't know why I put it all the way over there, but b equals 30. So right now we have to pick another point that we like on the line, and I think I'm going to pick this right here. It has to be on the line though, right? So I'm going to make my triangle, and I'm going to put -1. Yes, this is going by ones, even though there's 2. See, this is like 27, this is 29, that is 1, and so is this. Let me move that down so you can see this is 1 as well. So the rise over run is -1 over 1. So the slope is -1. And the b is 30. Write the equation. We are going to write y equals mx plus b. And we are going to have an equation of y equals -x, you don't have to put the 1, plus 30. Explain what the slope means and y-intercept mean in the context of the problem. So we started with 30 minutes, right? So 3-mile running times. So the initial value, I'm going to write that down, the initial value, the initial time, and you could put the initial 3-mile running time. Three-mile running time was 30 minutes. Right? So as the weeks went on in the training program, look at how the times for the 3-mile run decreased. Because the person was getting faster and faster, and that's it. So decreased 1 minute every week in the training program. And that was the rate that they decreased. They decreased 1 minute every single week in the that they were in the training program. All right, and that is an approximation, right? This is a trend line, so it's not a perfect number. It's not a perfect calculation. Trend line is a prediction, the best that we can, of future values. Right, and that's it. All right, so let's go on to number 11. If a line contains the points listed in the table, the equation of the line is one of these equations. All right, so to get an equation of a line, so equation of a line y equals mx plus b, we need two things. We need the slope, we need the y-intercept. So the slope of 2 points, I'm just going to pick one, x1, y1. I'm going to avoid these 2 points because they have negatives. And this is x2, y2. So I am going to figure out the slope, because the slope is pretty straightforward for me. x2 minus x1, and we can maybe get the answer just figuring out the slope. Minus minus. y2 minus y1 is 3 minus 5. And x2 minus x1 is 1 minus 0. So I'm going to bring the, should I bring the calculator? No, I don't need the calculator. 3 minus 5 is -2. 1 minus 0 is 1. So the slope is -2. Slope is -2. Slope of -2, that's A. Slope of +2, that's B. Slope of +5, that's C. -5, that's that. A is your answer. Let's see how we can get the y-intercept, though. Can anybody tell me what the y-intercept is? Yes, the y-intercept is 5. It says it in the table. When x is 0, when x is 0, the other value, the y value, is the y-intercept. So I put it right down on the bottom just to remind you that this is extremely important. When the x is 0, the y value is the y-intercept. So right here, and if you don't believe me, you could just sketch it. Not that you wouldn't believe me, I'm just saying. 0, 5 is up here. You see how it crosses the y-intercept? The y-axis. So that is the y-intercept, the 5. Right? A is your answer. Number 12, John left his home and walked 3 blocks to his school, as shown in the accompanying graph. Explain where John was walking the fastest and how can you tell? All right, so the one thing that I want to make sure that you understand is that you have to realize the first thing that you are going to look at, the y-axis and the x-axis, what they have labeled. Right, this is the distance away from John's home, and this is time. And x-axis is usually time. So this is your x, this is your y. Okay, the distance. So right now, if you start right here, time is 0, distance from John's home is 0. So if he leaves the house right here, he's walking, then this right here is the distance. So I'm going to say that these are, I'm just making this up. This is miles. All right. So now at the 1 mile mark, he changes his rate, and the line looks steeper to me from A to B. All right. So from 1 mile to 2 miles, another mile, that is a faster rate. The line is steeper. Then from B to C, time is going by, but he's staying the same amount away from his house. So that means he's not walking anymore. And then, finally, from C to D is another mile, right? Looks kind of like this, like from the beginning. So A to B, from A to B is the fastest rate. So we put that down. John is walking the fastest during the A to B interval. All right. The line is steeper than the other intervals. During the other intervals, you can see the steepness of this line, which means his rate of walking was faster. A to B. All right. Remember, from B to C, that means he's taking a break. That means he's taking a break. Time is going by. No distance is being covered. All right. We always look at those labels. Write a line that is parallel to y equals 3x plus 1. So what has to be, you have to know what has to be the same, what has to be different for parallel lines. So take a look. Parallel lines have the same slope with different y-intercepts. Remember, you have to pick the same slope with a different y-intercept. So if you have y equals 3x plus 1, and you're writing a line that is parallel to that one, you must say the same slope with a different y-intercept. These are parallel lines. Remember, if you have y equals 3x plus 1, you could also put just y equals 3x. That's a direct variation. Direct variations go through the origin. So, same slope, different y-intercept. All right, and that is that one. Number 14, explain how you can tell if a line of best fit is a good model for a set of data by looking at it. All right, explain how you can tell if a line of best fit is a good model. Well, the line of best fit is a good model for a set of data is when it goes through the center of all of the points. It goes through the center of all of the points. So you can tell a line is best fit is a good model if it goes through the center of all of the points in the set of data. So now, how can you tell if the correlation coefficient is good? So you can tell right here if the correlation coefficient is -1 or close to -1 or 1, that means it is a very strong either positive or strong negative. So the closer to 0, the weaker that association is, that correlation coefficient. So you want a correlation coefficient that is either very strong negative or very strong positive by being close to -1 or 1. Now we're talking about residual. When is that a residual plot, when is that good versus bad? All right, so that's it. So the residual plots, you know if the points are scattered above and below kind of equally below that x-axis, the trend line is a good fit for that linear scatter plot, like where you draw that trend line and it's linear, you could draw a nice trend line, and that residual plot would be scattered above and below. If the plot shows a U shape, that is not a good fit. So that means that trend line cannot be drawn and say it's a good representation for that scatter plot. And that's number 14. All right, number 15, the cost to rent a boat includes an initial fee of $20 plus $2.25 per hour. Write an equation that models this relationship. Take it slow. We're going to have right now initial fee, keywords. Initial feet? No, not initial feet, initial fee. So we'll fix that right now. Imagine an initial fee. All right, so initial fee of $20 and plus that $2.25 per hour. Write an equation that models, okay. So initial fee is B, so that B is 20 per hour. That is the slope, the rate that you're paying. So y equals mx plus b. We're just going to have to substitute those numbers in. You get 225x. The coefficient before the x is the slope, the rate, plus the $20. And that is it. Number 16, which function of x has the greatest value for the y-intercept? So this is pretty easy. Y-intercept, just put it on there. Just put a dot right there. B equals -2. You notice I rushed to the graphs because you can see it. It's visual. So this is greater than B so far. B for the y equals 2x minus 3 is -3. And B for this one is 15. The greatest is 15. A is your answer. All right. Number 17, what can you conclude about the graph of the line by the given equation? Y equals -3x minus 3. The line has a slope of 3. Does it? No, it does not. It has a -3. That's out. The line has a y-intercept of 0, -3. The y-intercept is -3. Oh, all right. So if you remember that every time this is the y-intercept, that this is the actual coordinate. So if you do sketch it and you say, all right, let's see, the y-intercept is -3, it'd be somewhere around here. That is 0, -3. That is your answer. The line passes through the origin. No, it doesn't. The y-intercept is -3, and it rises from left to right. That would have to be a positive slope. This is a negative slope, so that's out. All right. Number 18. Which statement best describes the data in the scatter plot where the y values are increasing as the x values are increasing? Okay. So, this really confuses me, so I love to sketch. Love to sketch. So this is your x, this is your y. X values are increasing, Y values are increasing. So increasing, so I'm going to make a little scatter plot. Everything's increasing, everything's increasing, everything's increasing, and increasing. The data can best be modeled by a vertical line. No, that's not a vertical line. Data by horizontal line? No. Data can best be modeled a positive slope. All right, so let's just take a look. Yes. Oh, there's my trend line. Let me start that, even though it's positive. Yes, it's not a negative, positive. So this is out. Remember, to answer this question, really just sketch something on the side. Sketch something on the side. Makes 2 seconds, and it takes 2 seconds, and you'll get the question correct. All right, number 19, the graph of the linear function y equals mx plus 6 passes through the point -3, 0. Which statement about the function is true? So they give you the equation here, and then they give you 1 point. The y-intercept is 0. So let me just write this down again. Equals mx, so we don't know the slope, plus 6. Well, I know that the y-intercept is 6. Y-intercept is 0? No, it's not. Y-intercept is 3? No, it's not. Slope is positive, slope is negative. You know the best way to do this? Sketch. All right, let's go ahead and sketch. So I am going to sketch this line. What else did they give you besides the y-intercept? Let's see. Hold on. The y-intercept is 6. So I'm just going to put that here. And by the way, that is a point, 0, 6. When x is 0, the other number is the y-intercept. Right there. They give you this, -3, 0. It's this right here, about that. Okay? I'm going to draw a line connecting those 2 points. And you tell me what you see, a positive or a negative slope. Negative slope? Nope, that is going up from left to right. C is your answer. That is it. Sketch. Sketch your line. Number 20. Describe the steps for finding the correlation coefficient on a graphing calculator. All right. Go ahead, look at your notebooks. Let's go through all of the steps. Okay, so this is everything that you need to find correlation coefficient. Remember, in order to see the correlation coefficient, you must have the diagnostics on. So just to bring up some of the calculator here, there's a couple of ways to put diagnostics on. Diagnostics on, you could, I think the easiest way is to just press mode. See this mode? So if you go down all the way to stat diagnostics, you see where I have blinking that's off. Normally your calculator, it will be off unless you turned it on already. But if you reset the calculator, by default it goes to off, the diagnostics. So if it's on off, which you could tell I just changed it to. Do you see how like that's off now? So I'm going to go back down to off, and I'm going to go and highlight on, and I'm going to press enter. And then I usually go up just to make sure. I press the up arrow just to see that it is on, and then I can press clear. Right? So the stat diagnostics, that would be on. The other way to do it is through the catalog. Right? So if you press the second function and catalog, you see this catalog comes up on your screen. Now you could press down, and you just keep on going down until the D diagnostics comes down. Now I'm just going to go do that. So if you have this right here, go down to D, and I don't see it yet, and this goes on forever, and diagnostics, there it is. Right, so diagnostics on. If you press enter, it'll go to its own screen. Diagnostics will be on, and you press enter again, and it'll be done, right? So it says done. Now there's an easier way to get to the D section of that screen. If you press second function catalog again, and you notice that you start with the A's. So do you see this button right here? It says alpha. If you press that button, you'll see an A right here, and then you're in alpha mode. So if you press this x to the negative first power, you see this D here? The D, I don't know if you can see it, but the D right here, it'll skip to, if you press the x to the negative first, it'll skip to the D's, and that'll give you less to jump down to. Now you could go to diagnostics on and press enter, and then press enter again. It's done. I think the mode is easier to put the diagnostics on, but you do whatever you need to do to get that diagnostics on. All right. So step 2, you input the X and Y points into your L1 and L2, right? So just remember, every time that you press stat and it's on edit already, you press enter, and you see that I put a list in already. So if you are on L1, you press 92, and then you press enter, and it'll automatically go down the list until you stop entering the numbers. And L2 usually represents the Y. You do the same thing. Put the number in, press enter, and then at the end you should have the same amount of X and Y's values, all right, in L1 and L2. Now you press stat again, and you go over to the calculate screen, right? You press once to the right, and then you go down to, you see this 4, linear regression. This is AX plus B. It's Y equals MX plus B. So you press 4, and then you go to this linear regression screen, and you have L1, L2, frequency list, store reg EQ, calculate. Press enter 5 times. Right? And you'll get this. This is Y equals AX plus D, MX plus B. The A is the slope. So the slope of the particular X and Y that I put in is 0.83. They usually have you round it to the nearest 100, but they could have you round it to the nearest 10th. The B, which is right here, is 14.068, which would be 14.07 rounded to the nearest 100. That is the y-intercept. So you're putting the equation of this together. You use the slope and the y-intercept. And the R is what we're looking for, correlation coefficient. So you have 0.924. Round to the nearest 100th, it stays 0.92. All right, and that is how you do it. All the steps are here. If you want to write them down, you want to pause right now and just make sure that you know how to do what you're doing. And then just one more step that I do want to show you. If you press stat and you go to the list again, if you want to clear the list, you go up to L2. Please don't press delete. Press clear. The clear button is right here. You'll notice that the L2 has been cleared. You enter and it clears, right? And then you go to L1, you do the same thing, you clear, and then you enter, and it clears the list of the data, not the list. It doesn't delete the list. Now, if you do delete the list, let's just say, all right, I'm going to delete, and look what happened. L1 is now gone. You don't want that to happen, and if it does, it's a mistake, but there's an easy way to get it back. All right, if you press delete again, guess what? L2 is gone now. Uh-oh, right? No, not that big of a deal. Press stat, and right down on stat, in the stat function right here, you have 5, setup editor. Go down to 5 or press 5, and it goes to setup editor, and press enter, and it says done. Now if you go back to stat and edit, the L1 and L2 that you deleted are there again. All right, so just make sure that you know the calculator and it's easy for you to use. describing the steps. This is a very important question. You need to know how to do this. All right, number 21. The scatter plot to the right shows the number of milligrams of a medication in a person's body for the first 3 hours after the medication is given. What kind of correlation does the scatter plot show? So, first thing that I always do is draw my trend line. So there's my trend line, and I am going to say that is a negative linear strong correlation. You should know what each one of these means. Negative means down from left to right. Linear, a scatter plot is very rarely completely linear, right? A linear scatter plot means that you could draw a trend line and it represents the data in a way that the data is not curving in any way. This data is not curving in any way. It's straight, so we say it's a linear scatter plot. And strong means that all of the data, all of these points are clustered right around the trend line. In other words, they're not really far away from the trend line. So if they were far away from the trend line, like if you had points over here and over here and over here, but it was still negative, that would be a weak correlation, right? This one is strong because these points are clustered around the trend line. All right, number 22. A company that manufactures radios first pays a startup cost and then spends a certain amount of money to manufacture each radio. If the cost of manufacturing radios is given by the function y equals 5.25r plus 125, then the value of 125 best represents the B. It doesn't say the B. All right, the B is the y-intercept. Y-intercept is the initial value, the startup cost. Is it the profit earned from the sale of one radio? No, right here. It's not even talking about profit. The amount spent to manufacture each radio. That's this. The average number of radios manufactured? No. All right, so we can cross those out. It's the startup cost. This is the initial value. Always the startup cost, the beginning cost, before even making one radio. All right, number 23. A satellite company charges a one-time installation fee. One time, that's B. The total cost is modeled by the function y equals 40 plus 90x. Identify the slope. So the slope is the number before x, y equals mx plus b. Don't get fooled that this equation is turned around like this, right? B is 40 and the slope is 90. Easy question. Which table of values represents a non-linear relationship? Non-linear. So there's a couple of ways we could do this. We could figure out slope of like twice, and twice should do it. If the slope comes out to be the same, that means you have a constant slope and that's linear. If it doesn't come out to be the same thing, the slope, that means it's a non-linear relationship. So quickly, you could just go ahead and put x1, y1. There are other ways to do this, but I'm just going to do this slope-wise right now. So m equals y2 minus y1 over x2 minus x1. Notice I do not like the negatives, so I'm just going to put y2 is 6 minus 1. Easy. Look how easy this is. So fast. M equals 5 over 2, 5 over 1. M equals 5. So this slope is 5. Let's see if I label this one. Let me do it in a different one. This is x1 now. This is y1. This is x2. This is y2. Let's see. I'm going to use y2 minus y1. So this is 13 minus 6. And then 3 minus 2. 13 minus 6 is 7 over 1. This is nonlinear. Which table of values represents a nonlinear relationship? This one. You could also look at the jumps. All right, so say if this jumps plus 1 and this jumps, how much is this jumping? From -2 to positive 1 is plus 3. And if this jumps plus 1, this should be plus 3, but it's not. It's plus 5. All right, so you could do that as well. Let's go check this one. This is x1. This is y1. This is x2. This is y2. So we're going to use the same formula, and look how fast. 3 minus 1, 2 minus 1. M equals, this M equals 2 over 1, which is 2. Okay, let's look at this as x1. This is y1. This is x2. This is y2. If it comes out to be the same thing, 5 minus 3 and 3 minus 2, that's 2 over 1. That is slope of 2. This is linear. Again, you could jump up, so this is a plus 1. This is plus 2. This jumps up by plus 1. From 1 to 3, plus 2. This jumps up by plus 1. This is plus 2. Linear. Remember, a linear function has a constant slope. The slope does not change, right? So nonlinear, the slope does change. That's why it curves. And that is it. Number 25. The graph represents the jogger's speed during her 20-minute jog. Which statement best describes that what the jogger was doing 0 to 2 minute during the 0 to 2 minute interval? All right, so let's go ahead and 0 to 2. 0 to 2 is right here. What was she doing during that interval? Take a look. Right? She was standing still. Well, this is speed. She's standing still? The speed? Like she's increasing? No, she's not standing still. She was increasing her speed. Well, she was at 0 miles per hour, and then 1 mile per hour, and then 2 miles per hour, and then 3 miles per hour. She was increasing her speed. B. She was decreasing the speed. No, decreasing speed would be over here. Right? That's out. She was jogging at a constant rate. Even though this looks like a constant rate, it is not a constant rate. And that's why I said you have to realize what the y and the x represent. So if the y represents speed, she is not jogging at the same speed throughout the minutes. Right? So at the first minute, she's already at this minute. This is 1 minute. She's already at over 1 mile per hour. Then at the second minute, she's already at 3 miles per hour. That's not constant. Even though it looks constant because it's a straight line, it is not constant. What is constant, though, is this interval. That's a constant. She's at 3 miles per hour, and she's running that rate for 2 minutes. At the 2 minute mark, 3 minute mark, 4 and 5 minute mark. At the 5 minute mark, she starts increasing her speed again, right, to 5 miles per hour. So you really have to pay attention to what is going on that y-axis. And that was number 25. And that ends the multiple choice part of the test. Part 2, open-ended. The cost of, remember, during this, in this part of the test, you have to show all work. The cost of renting a moving van can be modeled by y equals 3.50m plus 19.99, where y is the total cost for m miles driven. State the meaning of the slope and the y-intercept in this question. Wow, it's a lot of times that we have that as a question. What's the meaning of each number? Okay, so I'm hoping that you could see everything here and you understand what we'll go over exactly what's going on. Number 26 is asking to state the meaning of the slope and the y-intercept, and here we have it. The cost of renting the van is $3.50 per mile driven. Right, the 350 represents the slope or the rate. And then the moving van has an initial fee of $19.99 that must be paid before driving the van. Right, $19.99 represents the y-intercept initial charge. So this is what you should put down as an answer. You get full credit for this, and that's the meaning of each. Okay, alrighty. All right, so the following table represents a sample of sale prices in thousands of dollars and number of new homes available at a price in 2017. Write down the correlation coefficient for the line of best fit, round your answer to the nearest hundredth, and then explain what the correlation coefficient suggests in the context of this problem. Okay, so a very good question. All right, this is number 27. Right, so we have, they just want the correlation coefficient, right? So just be careful about this one because it says in thousands of dollars, and I get confused when they use different letters than X and Y. So you know that in the X, the X values are going to be on the top right here of a table. They very rarely put like a backwards table because the X is the independent variable, the input, and this is the output. And it says F of P. That's the same as the Y. All right, so once we have that down, so in thousands of dollars, so this is 160,000, this is 180,000. So be careful when you're putting this in. So I'm just going to bring this up, and the first number I'm going to put in is 160,000. All right, you could do this with me, 160,000. All right, then the next X, I'm going to put 180,000. And then 200,000. Right? And then 220,000. And 240,000. 260. And then 280. And just looking over, just make sure you have thousands in, and then on the bottom is just the Y's, and it's just it says just put those in. It's not in thousands or anything like that, so you could just go ahead and just input them in just like you see them. 126, 103, 82, 75, 82 again, 40, and 20. All right, notice that I do have the same amount of X and Y's, right? So that just, if you have one more X than Y in like L1 and L2, it'll give you an error. So just check at the end. All right, so now you could press Stat, and you could press Calc. Go down to 4 for linear regression and press Enter 5 times, and you have your correlation coefficient. You also have the slope and then the y-intercept, but they're not asking for that in this question. So you're just going to write down the r, which is the correlation coefficient, as negative 0.95. And it says rounded to nearest hundredth. That 5 stays a 5 because the next number is a 4. Let me get out of that next hundredth. This is the correlation coefficient. So explain what that means in the context of this problem. Okay, so there it is. So being that it's a correlation coefficient of negative 0.95, there is a very strong negative correlation between the sale price, and the number of new homes available. All right, and that's how you have to state it. And I just want to make sure that you understand that very strong negative correlation between those two, and you just copy down the two variables, what they say. They are sale price and number of new homes available. I always bring this graphic up, like when you have that negative 0.95, you're over here somewhere. All right, very strong negative. All right, and that is it for that question. Number 28 on the table below represents the residuals for line of best fit. Plot these residuals on the set of axes below, on the axes below. Right, so here we go. Oh, they're very nice to give you a table that the actual minus the predicted is already done for you. The residuals are already figured out for you. So this is your x, this is your y, this is the residual, right? It's like your y. So we are going to start graphing, and when we graph, we have to label the graph. All right, we have to label the graph here. So I decided to go. I decided to go ahead and label the x by halves, really, and skipping one in between. So this would be 0.5. This is 1. This is 1.52, and I went all the way up to 9 because the table goes up to 7. Right, but looking at this right here, I have to really be careful because I have to cover up to at least 6.6. So I'm just going to label them by ones. It's not the best graph for what we have here, but I mean, this is the only thing you could do. And so we're going to label them that way. All right, so now we're going to take, when you plot in a residual plot, you're taking the x and the residual. All right, so when x is 1, this is how I have to say it to myself. When x is 1, the residual is 1.3. So when x is 1, the residual is 1.3, which is right about there. When x is 2, the residual is 1.9, which is right about here. When x is 3, the residual is negative 6. So 3, negative 6.4. Let's see what this goes. 4. When x is 4, the residual is negative 0.7, which is right here. When x is 5, the residual is 2. That's nice and easy. And when x is 6, it's 6 points. The residual is 6.6, which is up here. And x is 7. the residual is negative 4.7, which is right about here. So using the plot axis, the fit line for these residuals and justify. Assess, not access. Assess the fit of the line for these residuals and justify. So you're going to take a look at this and you're going to say, all right, look at it. So you can either justify it as saying that it is a good fit or it's not a good fit, and why. And using the plot, we had to assess the fit of the line for the residuals and justify. So the residual plot represents a good fit for the data because the points are randomly scattered around the x-axis, right? That horizontal axis. So the linear regression model is a good fit. It's appropriate, right? So if there was a U-shape of some sort, then it would not be an appropriate linear regression model. All right, and so that is it. All right, number 29, the values given in the table below lie on the graph of a linear function. Create an equation. That's it. Create an equation that represents the data in the table. So if we have to create an equation, we know that we have to have y equals mx plus b. I'm going to do this in two ways. First way we showed you in class. Actually, in class. We showed you live and we talked about it. We need the y, we need the slope, and we need the y-intercept. We don't have the y-intercept right now, so we're just going to go with the slope right now. So this is x1, this is y1, this is x2, this is y2. All right, easy, right? y2 minus y1 over x2 minus x1. So we are going to, y2 was 1.75 minus 1.00, which is 1. And x2, which is 0.50 minus 0.25. So let me bring up the calculator for that. So I'm going to press alpha x. I'm going to bring up the fraction symbol, 1.75 minus 1 over 0.5 minus 0.25. Enter. 3. M equals 3. That's why you always use the calculator. All right. So we have a slope of 3, but we do not know the y-intercept. So what do we do? Slope is 3. Well, this is method number 1. So we are just going to use the point slope formula. Y minus y1 times x times m equals m times x minus x1. So y minus, I'm going to go with the y1 is 1. The slope is 3. The x1 is 0.25. It's not that difficult. Y minus 1 equals, then you do distributive property. 3 times x is 3x minus 3 times a negative 0.25. So 3 times negative 0.25. Don't leave anything to chance. It is negative 0.75. Then you add 1 on both sides. Y equals 3x and negative 0.75, plus 1. So you just have to press plus 1 because it's negative 0.75 plus 1, and enter. It is plus 0.25. create an equation that represents the data in the table. This is the equation. You are finished. Another way that you could possibly do this without the point slope formula, so you're using the slope formula and then the point slope formula. Right, to get the equation of the line in slope intercept form. But you could still see if you're a good pattern person, right? So like if you're going to work backwards in this table, you have to work back to where x equals 0. So if you could do that, this is a minus 0.25 and it jumps to from 0.75 to 0.50. Then it's a minus 0.25 again, jumping from 0.50 to 0.25. If you jump another, if you go back another minus 0.25, that is x0. That is when x equals 0. So let's go see what is happening here though. We're subtracting 0.75. And then we're subtracting again 0.75. And if we go back one more, we'll get 1 minus 0.75 is 0.25. This is the y-intercept. All right, you just use the table if you can. If you can't, then I would say use the point slope formula. There's also another method that you can use that I did not show you. So say you use the slope formula and you get the slope is 3, just like you did right here. Then you could use this, and when I put 2 here, this is the second, this is the third method. All right, so this would be the second method, and then this would be actually the third method. So let me put this in a different. This is the third method, right? So that you figure out the slope formula, and the slope use the slope formula, and the slope is 3. So then you have the slope, and you could actually use y equals mx plus b to solve for b. Now hear me out, we haven't done this in class, and we haven't showed you on any live meet or anything like that. So let's go ahead and substitute in what we have, right? We have a y, right? I'm going to use this y. I'm going to put 1 equals, and we have the slope is 3. We figured that out. When the y is, see this, when this y is 1, the x is 0.25 plus b. Right? We don't know the b. We want to get the b. We want to find that y-intercept. So 3 times 0.25. 3 times 0.25 is 0.75. So 1 was 0.75 plus b. Then you solve for b. Minus 0.75. And now you get b, this cancels, b equals 0.25. And then you can go ahead and create the equation. It's 3, the slope is 3. The y-intercept is 0.25. You get the equation in a line. 3 different methods on how to do that problem. You pick one, stick with it. All right? All right. 30, finally at the last question. Line N passes through these points 3, 7, and 2, 5. Dahlia, determine that the equation of this line is y equals negative 2x plus 1. Explain the error. They're telling us that Dahlia made an error already, and be sure to include the correct equation in your explanation. So let me just go down here. So this, I am going to label this x1, y1. I'm going to check out, this is x2, this is x2, this is y2. I'm going to check out if Dahlia is correct as far as the slope goes. I'm going to use the y2 minus y1 over x2 minus x1. So my y2 is 5 minus 7, which is the y1, and then the x2 is 2 minus 3. So I'm going to check that out in my trusty calculator. I'm going to press alpha x and bring up 5 minus 7 and then 2 minus 3. And then enter. That is 2. 5 minus 7, that's negative 2. It's 2. Alright, so she made a mistake on the slope. Alright, so Dahlia made an error calculating the slope. Positive 2 instead of negative 2. Let's go one step further though. She made an error there. Let's go and check out the y-intercept, see if that is 1. So I'm going to use the point slope formula. Y minus y1 equals m times x minus x1. It's just the easiest way for me. So I have y1 as 7 and the slope is 2. Nice and easy with all positive numbers, and the x1 is 3. I'm going to do distributive property. This is 2x. 2 times x is 2x. 2 times negative 3 is negative 6. And then you add 7 on both sides. Add 7 on both sides. This cancels. Y equals 2x plus 1. So Dahlia had the correct y-intercept. But she didn't have the correct slope. She put a positive 2 instead of negative 2. So Dahlia made an error calculating the slope. The equation, the correct equation is this. Is y equals 2x plus 1. So that is the end of our review sheet. Hopefully that video did help you out. If you have any questions, please get in touch with us. Thank you, as always, for watching.